Chapter 2 Fundamentals of Electric Circuits. This chapter guides you through the fundamentals of an electric circuit. 1. The resistor. As their name suggests, resistors resist electric current. The resistor controls the currents and voltages in the circuit so that the entire circuit runs smoothly. Here is a simple illustration. Supposing you have a light-emitting diode, LED, that you want to turn on using a 9-volt battery. If you connect the battery directly to the LED, current then flows through the LED. In fact, way more current than the LED can hold flows through it. The LED gets burnt out. On the other hand, a resistor, put in series with your LED, controls the current flowing through, so that the LED does not burn out. 2. Capacitor. To correctly understand the capacitor, think of it as a battery that has insufficient capacity. In simpler terms, this is an overglorified battery, so to speak, that gets charged and discharged in the same way a battery is. The capacitor's work is to introduce a time delay in your circuit. A capacitor is most commonly employed to remove electrical noise. In other words, it ensures that the circuit voltage is as stable as possible. 3. Light-emitting diode. LED. An LED is a component with the capacity to give light. An LED is vital in that it gives you feedback from your circuit. For example, if your circuit indeed has power running, the LED lights up to show this. You can also use the LED to add to the aesthetics of your circuit by lighting it up, but this is not a necessary use. 4. The transistor. The transistor may well be the most difficult electric circuit component to comprehend. To help you understand it better, think of it as a switch that is controlled by an electrical signal. If you run, say, 0.7 volts between the emitter and the base, this switch is turned on. However, rather than have just two states, on and off, this switch also has the bit on option. By controlling current that runs through its base, just a bit of current running through the base provides current amplified to 100 times. This is dependent on the transistor you are using. It is this effect that is used to construct amplifiers. 5. Inductor. The inductor is somewhat weird. The inductor is a coil of wire, and you can quickly make one by making several loops on some wire. At times, the inductor is wound around a metal core. Inductors act as filters in the circuit. 6. Integrated circuit. IC. The IC comprises multiple electronic components, but all it is at the end of the day is an electronic circuit that is so compressed that it can fit inside a small chip. The IC could play any role. It could be a microprocessor, an amplifier, a USB to serial converter. It could well be anything. The IC plays whatever role it has been installed to play in your electrical circuit. Your understanding of the different terms we have discussed above helps you understand much of what will be discussed later on. Next, let us understand how solar panels work so that you install the whole system with knowledge, not just following steps.